CTS, Combined Technology Solutions, is the name of the company, and that's not an accident. We combine technologies of all kinds to create solutions. Internal combustion happens to be one of the things that, one of the specialties that we do very, very well. We were part of a plasma research team at MIT in the early 90s, and we raced for a living for 25 years, professional drag racing, pro stock and modified. So it was engine development, so it was engineering, straight commission engineering. If you didn't do well, you didn't get paid. Pretty simple. In 2008, the X Prize Foundation offered a $10 million prize for a car that could get 100 miles per gallon. Mathematically, on paper, it looked like we could get to 70, 80 miles per gallon without any hybridization. That is, just on the internal combustion engine itself, with the efficiencies of our plasma technology and lean burn methods of operation. Our baseline technology is actually allowing the engine to use a lot more air without using more fuel. Most people do not understand how that can possibly work, but the more air you put into the engine, the leaner it is, actually the more efficient the engine gets. That's the technology, the base technology. So to get more air, you need a supercharger or a turbocharger. With these little engines, the 1.3 liter engine, we can get 400 to 600 horsepower out of a 1.3 liter engine. We have street cars that we've done which have 6 liter, 4 liter engines, and they're over 1,000 horsepower. In my racing days, we used 500 cubic inches with no fuel injection, just carbureted, and we made 1,500 horsepower, naturally aspirated. When you start talking about horsepower, you say, well, it takes a lot of fuel to make that horsepower. But when you measure how much fuel per horsepower that you actually use, the efficiency is very, very good. So if you can transfer that to the automotive market, to the street market, all of a sudden you're using 10, 15% less fuel because the engine's much more efficient. Today, with the computer systems, it can think of things and control things so quickly that it can fool engines into better efficiency. With our technology, we blow more air into the engine, and as we do that, we require less and less fuel to make the same horsepower. So the magic metric that we use for our 100 mile per gallon effort, which we did achieve 72 miles per gallon officially in 2010, we're over 84 miles per gallon now. We're hoping to get closer by the end of this year to the 90 mile per gallon mark, is at 40 mile an hour, 60 mile an hour in a Cadillac CTS, which is just totally coincidental to the company name. That car needs 40 horsepower to go 62 miles an hour. And we drove from Ridgely to Ellicott City and back. That's 84 miles one direction. There's a Shell station at each end. So you fill up, you fill up, you fill up, you fill up. So you have 100 trips that way, and that gives you a pretty good backup on what the real fuel consumption is in real driving conditions. That particular scheme of 40 horsepower and doing it very, very well will cross all the boundaries of all the engines. It doesn't matter if it's a V8, a V6, a 4-cylinder, a little 4-cylinder, or a V12. 40 horsepower done very efficiently is where the gas mileage is. We do testing for drone engines for United States Army, some projects for the Air Force, some projects for the Navy. So that's a little spoke coming off of our hub. Then we have automotive lean burn technologies, another little spoke off of our hub. So that's a very specific marketplace, and that automotive lean burn technologies could be to GM or Ford, but more close to home is retrofitting trucks for perhaps UPS, Federal Express, even smaller fleets, or maybe even salesman cars that are putting 100,000 miles on their car a year. They can afford the technology it takes to get higher miles per gallon. Then the next thing is natural gas pipeline engines. These pipeline engines are bigger than a tractor trailer, and they pump natural gas from Louisiana to Boston. Today with fracking, they're also pumping natural gas from Pennsylvania to South Carolina. So now you have two-way traffic on the pipeline. These engines have to meet the most strictest EPA regulations, which new regulations were just passed a couple years ago, and they have another 3 or 4 years to go ahead and be in compliance with those. Our technologies help them do that in a very cost-effective manner. We have engine dyno systems that actually measure horsepower and efficiency of engines. That's our forte, if you will. So we've done that for the United States Army, we've done it for Williams Pipeline Company, we've done it for Dominion Transmission Company, we've done it for the Department of Energy now. We received our first award, which is called a SBIR, Small Business Innovative Research Grant. And that is kind of putting us into another level of credibility, because now we have credibility within the automotive market that the technology works.